Yes. Yeah, last Friday fully discussed all types of resistance systems, how to calculate the equivalent resistance of every types of resistance systems. Different application examples we discussed. Okay, today I'm going to start our new part, the electromotive force. The electromotive force. Okay, this is the most important part of the lesson. After electromotive force, I hope to start our new section, the Kirchhoff flow calculations. This is the most important and most advanced part of the lesson. Therefore, it's you have to careful and complete everything without any part missing. If you miss any part, it is very difficult to understand. Okay, this is the most important part. Kirchhoff laws. The Kirchhoff laws, mainly two Kirchhoff laws. This is the first law, same as Newton's law. The Kirchhoff is another scientist. This is the Kirchhoff second law. Okay, let's see. Okay, before moving to Kirchhoff's law, I am going to explain what's the meaning of this electromotive force. What do you think? What is the meaning of this electromotive force? Electromotive force, it's a force due to electromotive factors. What is the meaning of electromotive force? Electromotive force. Electromotive force. Okay, think. Okay, think this is a conductor. Think it's a conducting battery. Yeah, battery. It's a battery. I'm explaining very basic level. Try to understand basic concept first. Okay, think this is a battery. This is a positive terminal of the battery. This is a negative terminal of the battery. Positive and negative terminal of the battery. Okay, what is the meaning of this electromotive force? The potential difference of this battery, may wage battery, just a battery. The electromotive force mean the potential difference of any battery or cell. See, the potential difference between the terminals of any electric cell. Electric cell mean battery when current is flowing. When no current is flowing. When no current is flowing. Okay, what's the meaning of this? The potential difference between the terminals of any battery when no current flowing. No current flowing. No current flowing mean in this stage before connect to a circuit. Before connect to a circuit, the potential difference mean voltage, right? In simply, the voltage of any battery before connected to a circuit, that we called as the electromotive force. Electromotive force, the potential difference, it has a, this has the positive side has higher potential, it's high potential. The negative side, low pressure, low potential, low potential, low potential. Due to this high potential and potential, high and low potential difference, there is force act high potential to low potential. This is the electromotive force. This is applied generate force from high potential to low potential. Okay, that is the electromotive force. Okay, then what is the definition of electromotive force? The the potential difference of any battery or electric cell when no current is flowing. When no current is flowing mean what? මෙයා circuit එකකට connect කරන්න කලින්. In this stage, think it is a new battery. Think it is a new battery. Make a new battery එකක් නම් before I connect this battery into any circuit, its potential difference between two terminals that we called as the electromotive force. I got simple. The potential difference. This definition is very important. Always asking the potential difference between two terminals. The potential difference between the potential difference. Please carefully remember this is potential difference. That means voltage actually. Try to get the practical understand. The electromotive force mean the potential difference between two terminals when no current is flowing of battery when no current is flowing. When no current is flowing mean before connected to a circuit. When I connect into a circuit, this battery, when I connect into a circuit, what happened? It's pass a current, right? Like this. Now think this is a battery. This is a battery. This is a positive terminal and this is a negative terminal. If I connect this battery into a circuit like this, think it is a bulb. And now what happened? Positive potential to negative potential, the current is flowing, right? The current is flowing. Current is flowing through this circuit. Then electrons flow into this cell. Due to this electrons, remember, due to this cell internal resistance and conductors external resistance, the internal resistance we called as simple R. It is very simple story, simple R. The external resistance we call conductors external resistance capital R. Due to this both resistance, the potential difference decreasing. When I connected to it, making current flow with the what happened? The potential difference of this battery, it's less than the electromotive force. It is less than the electromotive force. I will write it simply. The potential difference in this time when I connect into a circuit, what happened? Due to internal resistance and external resistance, the potential difference less than the electromotive force. Okay, this is a story. Okay, now what is again revise? What's the meaning of electromotive force? Electromotive force is the potential difference of both between two terminals of any battery before connected to a circuit. In this state, if it is new battery, the potential difference, electromotive force it's calibrated on the battery. It's 1.5 volt. 1.5 volt. That's meaning before connected to a circuit, the potential difference. This is the electromotive force. But when I connect into a whatever circuit, is it electromotive force 1 point make a potential difference 1.5 තියනවාද අපි connect කරාම? No, due to this external resistance and internal battery resistance, the potential difference decreased than the electromotive force. That means අපි හිතමු as example, this now initially new stage before connected to a circuit, it has potential difference 1.5 volt. This is the electromotive force. Okay, this is the electromotive force. But when I connect it to a circuit after 1 hour, if I got this battery, if I separate this battery and check the voltage, what happened? It is around think initially 1.5 volt. After 1 hour, it's around 1.3 volt like this. What is the reason? It is less than. When I connect to a circuit, the potential difference less than the electromotive force. Less than the electromotive force. This is the electromotive force. This is the electromotive force. When I connect it to a circuit, the potential difference getting less than the electromotive force. What is the reason? Battery internal resistance and conductors external resistance. Okay, are you clear or do I need to explain again? This is very important. You can ask again if you have any doubt. Tanya, Dini, Samya, understood or no? Others, quickly. Today we have a bulk part to discuss. Therefore, we have to manage our time. That's why I'm doing it rapidly. We have a lot of calculations today, more advanced calculation. Therefore, don't miss any part of today. Okay, I'll explain simply again. Hari, අපි මෙහෙම battery එකක් කරන් තියෙනවා. It's a new battery, okay? It's a new battery. Now it has a voltage value, no? It has a voltage value. It has a voltage value. This is the electromotive force. The electromotive force means the potential difference of any battery, the potential difference between two terminals. That's a voltage, no? The potential difference of any battery of the between two terminals before connected to a circuit. That means no current is flowing before connected to a circuit. Okay, that is a normal electromotive force. Okay, but if I connect it to a circuit like this, the current is flowing from positive direction to negative, right? Positive to negative current flowing. Due to this internal and external resistance, what happened? The potential difference decreasing. The voltage decreasing. Now the voltage decreasing, therefore we call potential difference. When I connect it to a circuit, potential difference decreasing. It is less than the electromotive force. Mea new condition it has electromotive force. What's the meaning of the electromotive force? The electromotive force is the potential difference of between two terminals of any electric cell when no current is flowing. When no current is flowing. When current is flowing, what happens? When current is flowing due to this resistance, its voltage, its potential difference getting less than the electromotive force. Okay? Joel, understood? Rehelan? Right. Let's move into next part. Normally, electromotive force we label as capital E. This is the electromotive force. When a cell is in a closed circuit mean as I given earlier. Closed circuit mean like this. Closed circuit without switch off. Closed circuit. The potential difference between its terminals or when the current flowing through the cell. When the current, the closed circuit can current flowing, right? Current flowing through the circuit. It's often less than the electromotive force. Yes, its potential difference less than the electromotive force. That's the most important point. It's less than the electromotive force. This is because there is a resistance in the flow, current through the cell. Yes, it has a resistance. Resistance is the reason. Okay, it is everything given here. The resistance within the cell called as the internal resistance of the cell. That's why I explained the resistance within a cell, within a battery. මෙයාගේ ඇතුළෙත් resistance එකක් තියෙනවා. That's why its voltage decreasing. Okay, the resistance within a cell is called as internal resistance. Okay, this is the electromotive force, capital E. Its volt value, its unit volt, because potential difference. Okay, this simple R, what is a simple R? It's internal resistance. Please name these terms first. This is electromotive force. Capital. Simple R, what is the name? Internal resistance of the battery. Internal resistance of the battery. What's the meaning of this capital R? What's the meaning of the capital R? This is the external resistance of the circuit. External resistance. It's not inside the battery, but it is a resistance. External resistance. What's the meaning of I? I is a current. Always. Now, if you got the closed circuit, now it's a closed circuit. Okay, in this closed system, the potential difference of this battery, it is less than the electromotive force due to this internal resistance and the external resistance. Internal and external resistance, the potential difference of the battery is less than the electromotive force. Okay, that's the story. Basic story. Okay, up to now, okay. If you have any doubt, you can ask. Okay, read this next point. Yeah, very important part. The electromotive force of cell is obtained when the potential drop due to external resistance and the potential drop due to internal resistance. The potential drop, a velocity, the voltage is decreased. I told when I connected to a circuit, when current is flowing, what happened? Due to external and internal resistance, the potential drop එකක් වෙනවා due to external and internal resistance. Okay, this is the point. The reasons, resistance and internal resistance, external resistance, that means capital R, potential drop due to internal resistance, that means simple R. Okay, they are the reasons. Accordingly, give me a second. Okay, sorry. Yeah. What's the meaning of the potential difference? Yeah, sorry, electromotive force. The potential difference of any battery when no current is flowing, right? No current is flowing. No current is flowing. No current as in new state. In new stage, no current is flowing. Okay, when I connect it to a circuit due to internal and external resistance, it has a potential drop, voltage drop. Voltage drop. What's the reason? Capital R and simple R. Accordingly, when a current flow through the cell, the potential drop inside the cell we called as capital, we called as I simple R, and the potential drop across the external resistance we call as capital I capital R. It is very simple this. Now think this battery has a external resistance. This bulb has external resistance. This battery, this cell has internal resistance. Okay, now the current is flowing. The current is flowing. If you want to get full electromotive force, capital E, electromotive force, it is equal to the summation of IR and I simple R and the summation of I capital R, because V equal IR, we can get voltage. According to Ohm's law, we can get voltage drops, voltage difference by IR, I multiplied by resistance, current multiplied by resistance. This is the final equation. This is the electromotive force. This is the electromotive force. If you want to get electromotive force, yes, this is IR equal V. Electromotive force equals sum of IR. You can, in the Kirchhoff laws, you can get this full idea. Still, I know you can't understand them. Plus simple IR, then E equal capital IR mean V plus I simple R. Now voltage equal, I can isolate this voltage. Voltage equal E minus I R. Okay, they are simple relationships. In Kirchhoff laws, I will explain how to get this IR multiplication and I simple R multiplications, everything point by point. Now, this is your basic knowledge. Okay, now summarize what we discussed up to now. What's the meaning of electromotive force? Can you say? What's the meaning of electromotive force? The potential difference between two terminals of any electric cell when no current is flowing. If it is current flowing, what happened? When I connected to a circuit, due to the internal and external resistance, capital I and simple R, it has it's coming a potential drop. Potential drop එකක් එනවා. Due to that, when I connected to a circuit, battery, when I connected to a circuit, the potential difference always less than the electromotive force. Okay, that's a story. That's only you need to remember. This IR multiplications we can discuss later. Up to now, okay? Please send me message if you have any doubt, because today lesson very, very important. Okay, Prehlan? Okay. Understood? Hari. Let's go to next part. This is the Kirchhoff laws. Same as Ohm's law can be used to calculate electric circuits and electromotive force in simple electrical circuits. Yes, Ohm's law we can use always for simple electric circuits. But the problem when the circuit become complex, we can't use Ohm's law. We can't use Ohm's law. For complex circuits, we can use Kirchhoff law and do conduct experiment, and we can find the current flowing through these circuits by using Kirchhoff laws. Okay, let's start Kirchhoff laws. I told Kirchhoff law mainly two types. It's mainly two types, the Kirchhoff first law and second law, same as Newton's law, right? Second law. Okay, let's move into Kirchhoff first law. Let's move into Kirchhoff first law. Okay, Kirchhoff first law actually very easy. Now you already know it. The Kirchhoff first law, the sum of the electric current flowing into any junction in a circuit, it's equal to the sum of electric current leaving out from the junction. It's very simple. See, now think it is a junction. What's the meaning of junction? Now it's a think this is an electric circuit. This is a battery connected to a, this is a external resistance. Now what are the meaning of junctions? Junctions in a circuit. Okay, if you got this part, is it junction? What do you think? This green color part, is it junction or not? Joel? Is it junction? No, it's only bend, right? Yeah, bend. Then what is the junction? Junction mean like this. This type points are the junctions. Okay. For this circuit, you can find two main junctions. This is a one, this is a point, this is a one junction, this is a second junction. This is the first one, this is the second one. Okay, however, what is the Newton's first law? The sum of electric current flowing into a junction. Think 20 ampere flowing into the junction, this junction. It's equal to the sum of electric current flowing out, leaving out from the junction. That's mean 12, if it is 12 ampere, this path always 8 ampere. That we call as current, what we call efficiency. No, current conservation, sorry, current conservation. We discussed in the work energy lesson, energy conservation. Energy conservation means energy cannot be created or destroyed, right? Samely, current conservation. The always new Kirchhoff first law explained about current conservation. Current conservation law. It's always explain current conservation, electric current conservation, electric current, the current flowing into the junction, it is equal to the leaving out, no any destroy, no any create or destroy. Okay, this is a very simple new Kirchhoff first law. The sum of the electric current flowing into any junction in a circuit is equal to the sum of electric current leaving out from the junction. Okay, see. Think it is a junction. Think it is I1, I2, and I3. According to Kirchhoff's first law, I1 always equal to I2 plus I3. That is a Kirchhoff's first law. It's explained about electric current conservation. Electric current cannot be created or destroyed. It is equal to leaving out. Understood? It is very simple. Kirchhoff's first law. Kirchhoff's first law. Okay, you have a lot of calculations and a lot of activities in electricity lesson. Therefore, try to get full practical idea. I'm only explaining theory. After that, I'm going to move into calculations. Okay. Now today what we discussed about electromotive force and we discussed about Kirchhoff's first law. Hari, what's the Kirchhoff's first law? In a junction of any circuit, the current flowing into the junction, the sum of current flowing into the junction, it is equal to the sum of current leaving out from the junction. Remember? Everyone? Tanya? Amina? It's easy, right? It's easy. Okay, the same thing given here. According to the geometrical sum of electric current flowing into or leaving any junction in, it is zero. Yes. Electric current is the amount of charge that flow per unit time that we already discussed. Thus, according to Kirchhoff's first law, the amount of charge that flow into a junction in a circuit per unit time. Yes, it is explained more about the same thing. More explaining same thing. The amount of charge flow into a junction in a circuit per unit time is equal to the amount of charge that leave out from the junction during the same time. Therefore, no charge remains at this junction. Yes, no charge remain at this junction. Or charge is created or no charge is created or destroyed. That we called as conservation of charge or conservation of current. Understood? Okay. Only you need to remember this basic concept. What's the Kirchhoff's first law? The current flowing into a junction, the sum of charge flowing into a junction within unit time equal to the sum of charge leaving out from the junction at the same time. Okay, that's a story. That's the Kirchhoff's first law. Very simple, no? Very simple. And let's move into Kirchhoff's second law. Okay, before move into Kirchhoff's second law. Okay. Can you say what is the I1 value? What is the current flowing through I1 path? What's the current flowing through I1 path? Okay, quickly. They are grade 5 questions. Don't take time. Rehlan? Good, Rehlan? Yes. Now you know what's the meaning of the Kirchhoff first law. No? Kirchhoff first law, great. Very simple. It's always explain electric current conservation or electric charge conservation. Electric charge conservation in a unit time, or electric current conservation. Electric current or electric charge cannot be created or destroyed. Same as energy conservation. Sarmia, understood? Okay, what's the answer? It is definitely 12. 12 ampere. Because current flowing into the junction, three currents. 12 plus 18, it is 30. 30 plus 20, it is 50. Now it is balance. According to Kirchhoff's first law. Say always explain charge conservation or electric current conservation in a unit time. Okay. Let's move into Kirchhoff's second law. Kirchhoff's second law is the law actual. Little bit complex. Hari. හරියට අහගන්න. Kirchhoff's second law. Kirchhoff's second law. Hari. ඉස්සෙල්ලා මම මේ කියවලා then I will word by word I will explain. The net electromotive force around a closed circuit the net electromotive force. Net electromotive force means, I will explain. Net electromotive force is an important word. The net electromotive force around a closed circuit. What's the meaning of closed circuit loop? Loop එකක් කියන්නේ මොකක්ද කියලා අපි දැනගන්න ඕනේ. Is equal to the sum of potential drops around the loop. Sum of potential drops. Sum of potential drops mean, remember, this is IR multiplications. Sum of potential drop mean IR multiplications. Or the sum of the changes in potential encountered in the complete travels the closed circuit loop must be zero. Okay, don't think about this second word, second sentence that you can understand later. First understand this first point up to this point. Okay, first you need to understand what is the meaning of closed loop. Okay, closed loop එකක් කියන්නේ, closed circuit loop එකක් කියන්නේ, it's like this. Closed circuit loop. It's like this. Now think it is a battery. Now it's a bulb, resistance, another battery, resistance. This is electromotive force, that means E simple R, capital R, capital R, capital R, E simple R. E simple R. Hari. What's the meaning of closed system? Closed system means closed circuit loop. Closed circuit loop means මෙන්න මේ එක කොටුවකට. Now this yellow color one is a closed circuit loop. That's the first loop. This circuit has two loops. Not actually two, three loops. We can get, this is a one loop. හරිද, මෙයා එක loop එකක්. This is a second loop, closed loop. This is the first one. This is the second loop. Additionally, we can get the overall outer parts. It is a third loop. Okay, this circuit has three closed circuit loops. Okay, මේ වගේ loop එකකට, now understand, circuit loop mean closed box, like box type circuit. Okay, closed box type circuit. The net electromotive force means sigma E. It is equal to the sum of potential drops around the loop. That means sigma IR plus I capital R, all IR product. Sum of electromotive force equal to the sum of IR product. This is the Kirchhoff second law. Hari, I know still you can't understand. It is the most advanced part of this lesson. Okay, let's try to apply into expression, right? Hari. Okay. අපි ගමු. I will copy one of simple circuit into my board and I will explain, try to get full idea. This is the most important part of the lesson. හරිද? හොඳට අහන්න. හරි. මෙහෙම. Okay, this is my circuit. Okay, this is the capital R. This is the capital R. E1, and this is the electromotive force 1 and simple R1, electromotive force 2 and simple R2. Okay. Harid. Okay. I'm going to do this question one step by step. Harid, step by step understand. Harid, my first step, I want to label this loop. Now it has only one loop. It has only one closed loop, but it has two batteries. Therefore, you can't use Ohm's law. It's a little bit complex. That's why we use Kirchhoff law for solve this question. Make a battery if it only one battery, we can use Kirchhoff, we can use Ohm's law and solve this question. Okay, now, Valanda, my first step. First of all, I need to label this circuit. Okay. Okay, I'm going to label A, B, C, D. This is my loop. Now, this is my loop that we called as A, B, C, D, A loop. A closed loop. The loop name. Now, it has only one loop. Its name is A, B, C, D, A loop. That we called as a closed circuit loop. Understood up to now? First step, my A, B, C, D, A. A, B, C, D, A. That's we called as closed circuit loop. First step done. Others, first step okay. First I label the loop. Haride? Tanya, sir. Amina. Okay, my second step, I need to mark the current direction. Mark the current direction. Okay, I'm select yellow color. Okay, I don't know. Now two batteries, no? I don't know. It's totally up to me. Okay, current direction we can decide up. Okay, I think this is the current direction. This is the current direction. The current is starting from this battery. We don't know E1 and E2, what is the highest voltage? We don't know. Highest potential difference. I think the current flowing through this positive to this direction. Okay, then this is the I. This is the I. The same current is flowing because no junctions here. No junctions. Okay, the same current is flowing through this entire path. Now, I have done two steps. What is my first step? Label the loop. Label the complete loop. What's my second step? Mark the current direction in assumed direction. Direction it can be changed, okay, but I don't know. Still, I don't know. My third step. What is my third step? I want to mark the electromotive force direction. I want to mark electromotive force direction. Always remember, electromotive force it has always battery. Electromotive force, I told always it is act towards to negative to positive. Negative to positive. Force this is the force direction always. always මෙන්න මෙතනින් තමයි අපි එක mark කරන්නේ. Negative to positive. That's the electromotive force direction. This is electromotive force direction. Right. Third step done. Electromotive force direction done. Right. Now I am going to use Kirchhoff's second law. I am going to use Kirchhoff's second law for this complete law. For this complete law. Okay, my first step. Now I am going to start A point. Now, label A, B, C, D. A is my loop. Okay, I am going to start A point, and check electromotive forces. Check E forces. Check electromotive forces. E tama hoyanyan. It is yes. I can meet E2. My direction, I am going to A to B. I am going to A to B, but electromotive force direction opposite to me. Electromotive force direction opposite to my direction. Therefore, it is minus E2. That's why we call it as net electromotive force. That's the meaning of net electromotive force. It is minus E2. Okay, continuously I am going until electromotive force meet. Okay, A to B, no any other electromotive force. B to C, no any electromotive force. C to D, it has electromotive force, but my direction, I am going to C to D. My direction and electromotive force same or difference? It's same, right? It's same now. It is plus E1. Plus E1. Hurry. Okay. Then come to again A point, no any batteries, electromotive forces. It is according to Kirchhoff's second law, it is equal to, I am again starting from A point. I am loop එකේ මේ යන්න ඕනේ. හොඳට බලන්න. Again I am going to same law. A to B. Now I am going to find resistance. Now resistance R2, simple R2 is an internal resistance. Then that we call I simple R2. I simple R2 is my first IR product. I simple R2. Okay, next you have to decide it is negative or positive. Okay, my direction and current direction same night. My direction and current direction same. Now you can keep it is positive. This is IR product, not electromotive force. Okay, B to C no resistance. C to D 2 resistance. Capital R is IR, I capital R, but my direction and current direction same. It's IR plus IR. Okay, again there is a simple internal resistance. My direction and current direction same. I am going to C to D. Then it is I R1. This is the Kirchhoff second law application. Are you clear? I know it is the most advanced part of the lesson. It little bit difficult, but make a steps ටිකක් theory. You can understand when you practice. Okay, what do you think? Dihini, what happened? Okay. Can you get your notebook and write down this step by step? මම කර විදිහටම කරා. You have to practice this. Without practice, you can't apply this type theorem in exam. In a limited time, you can't do this. First, you have to understand well. Then you have to practice. Yeah, E2 comes negative. E2 api electromotive, when we take electromotive force, we always compare our direction and electromotive force direction. Tanya. Now I'm going to A to B according to my label. A, B, C, D, N. I'm going to A to B, but E2 cell electromotive force opposite to me. That's why it is negative. But when I go into this, through this cell, it is same as my direction. That's why E1 positive. Api electromotive force ganidhi always think electromotive force direction and my direction. Electromotive force direction and my direction. When I get IR product, we always consider current direction and my direction. That is a point. මෙතනදී අපි හිතන්නේ E direction and my direction. If it is same, it's positive. If it is opposite, it's negative. In IR product, current direction and my direction තමයි හිතන්නේ. මම යන path එක තමයි හිතන්නේ. Okay. If you want, you can note down there for you better understand. Then on second question, you can easily adapt. You can easily apply this into circuits. Amina, any doubt? Please ask. Complete. Sarmia, what happened? It's little bit advanced. Okay, complete writing. Okay, let's go to another one. Appear map for this second one. Okay, let's try for this question. Okay, quickly draw this. මාත් එක්කම කරමු. Okay, what is the first step? What's the first step? Label this circuit. Okay, sometimes they provide letters. If not, you can add your any that's according to your preference. Any pattern you can use, A, B, C, D, or P, Q, R, S, O, whatever letters you can use. Okay. Now, what is the next step? Mark electromotive force direction. This is the direction. This is the direction. This is the direction. Third step, current direction. Current direction. The problem, I don't know what is the direction now. Okay, I think this is the current direction. I, 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 I. Okay. Now everything is ready. Everything are ready. Hurry. Okay, I'm going to use now. It's not compulsory A B C D A use karandonne. We can use D C B A D for you understand. Okay, if you got A B C D A, it's easy, but I'm going to use different one. D C B A D. D C B A D loop Kirchhoff second law. Apply Kirchhoff second law. Okay, can you try this? Joel, can you try this? Okay, you have to start D. First, you have to find electromotive forces. D to C. Only one battery. First, you have to find battery. Then it is my direction and electromotive force direction opposite. Therefore, minus E1. Minus E1. Minus E1. No battery again. C to B, no battery. B to A, there is a battery here. My direction and E3 direction opposite. Minus. Again, A to D, opposite. Minus E2. All are minus. No problem. All are minus, no problem. In calculations, you can understand. No problem. Equal to, now IR product. You have to use same pattern, same path you have to follow. D to C, D to C. My direction and current direction opposite. Therefore, minus I simple R1. My direction and current direction opposite, minus I capital R1. My direction and current direction opposite, therefore minus I R2. My direction and current direction opposite, therefore I R3. My direction, current direction opposite, therefore minus I simple R3. We have to follow up to D. Then my direction and current direction opposite. My direction and current direction opposite, right? I'm going to A to D, current flow into D to A. It is again minus I R2. Any doubt? Are they clear, right? Amina? Pehla? Fatima? Okay. Fatima, understood? Okay. අපි තව එකට let's move into next question. I hope now you are working on this circuit, these tutorials. Where I which tutorial I added these questions? Tutorial 1, no. Tutorial 2, no. No. You have separate මේ වගේ කොලයක් ඇති. Do you have in your tute pack? Send message. Go to this paper. First go to questions without numbers. මෙහෙම කොලයක් තියෙනවා. With 4 questions. Without numbers, only symbols. Amina, found this paper? Rehlan, Samia, you define? Okay, you have to complete question part 1. It's very easy. First part. Question part 1. Yes, this is our. Yes, this one. Please find in your tute pack. Okay. Current. Okay, what is my first step? I have to label this circuit. A, A, B, C, D. This is my label. Okay, I'm going to, yeah, it has only one circuit, one cell, one battery. Because current always flow into positive to negative. This is the current direction. This is the current direction. Okay, I'm going to use Kirchhoff second law into A, B, C, D. The easy way, A, D, C, B, A. A, D, C, B, A. A, D, C, B, A loop. This is my loop. Okay, now I'm going to find A to B, no any battery. B to D to C, no battery. C to B, no battery. It has only one battery. It is positive because my direction and electromotive direction same. It is E equal to. I'm going to start again A, no resistance. It's capital R2. Then I capital R2, current direction and my direction same, positive. IR2. Next, current direction and my direction same, positive IR1. IR1. That's all. Sorry, there is an internal resistance. My direction and current direction same, IR. Okay, this is the Kirchhoff second law expression. Question number 1. According to a loop that can be changed. It's okay. In calculations, you can understand if you expression change, if you apply this same theory, if you apply this concept correctly, all methods, it's coming same answers. If you got A, B, C, D, A loop, if you got A, D, C, B, A loop, same method. If you correctly apply all theories, all concepts, you can get same answers in calculations, mathematical calculations in our next part, next paper. Hi. Okay. Question number 2. They are the electromotive force. Electromotive force directions. Okay, it's A. Now I will change it PQRS. 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 How about current direction? Always current positive to negative one. Then I. This is the current direction. Okay. Now I'm going to use PQRS P. PQRS P. PQRS P. P loop. PQRS P loop. Okay. Tell me PQ. Two cells, two batteries. Then R1 and R2, both opposite direction with my direction. Then both negative. Both negative. E1 minus E2 equal to again going through same path, IR1 negative, simple IR1 negative, IR simple 2. Again another 2 resistance, external resistance, both negative, minus IR2 minus IR1. Okay, this is the expression. Okay, any doubt? Dihini, everything okay? Fatima? Okay. Yeah, it's same, simple, right? Again, same circuit, you can try. I don't need. It's capital E1, R1, E2, R2. Okay, you can try. It is same thing. Okay, I'm going to final one. Yeah, the final one is the most important one. Alright. Okay, I'll draw this now board. Okay, think this is R1, R2, and R3. E1, R1, E2, R2. Simple R. Always battery has an internal resistance, right? Hi. Okay. Now can you try this? Can you try this? Okay, how many closed loops of this circuits? How many closed loops? Joel, how many closed circuit loops? not 2. It has 3. See, this blue color I'm drawing, this is one loop. This is another loop. 2. 1, 2. But if you got the full circuit as a one loop, it is 3. Without this middle one, without this middle path, that's the third one. Understood? It has 3 closed loops. Joel, understood? It has 3. Okay. Remember, when single circuit, while single circuit available more than one loops, you have to apply Kirchhoff law at least 2 loops. At least 2 times you have to apply Kirchhoff law. Okay, apply at least 2 times for 2 loops. For 2 closed loops, you have to apply Kirchhoff's second law. Okay, I will explain. Okay, I'm going to label first. I'm going to label this. Okay, first one, A, B, C, D, E, F. This is the circuit labeling method. Next step, mark the electromotive force direction. Mark the electromotive force direction. What is my third step? Now you can remember. Rehelan, what is the next step? What's the next step? Mark the current direction. How to? Okay, I think now this is the most important step for this type complex circuits, more than 2 loops, more than 1 loops. Okay, I think the current is start from this battery. It is I. Now there is a problem. It has a problem. What is the problem? The current meet a junction. The E is a junction, not a bend. F is a bend, it's no problem. But E is a junction. Then what happened? Kirchhoff first law. In a junction, the entering current, it is equal to the leaving current, no? The leaving current. Then I can say I1 current flowing through the right side path. Then what is this path into downward? It is always I minus I1. Okay. If you have any doubt on this point, please ask. It is I minus I1 because I minus I1 equal to this path. As example, think it is 20 amperes. Okay, 20 amperes. 20 amperes coming to this junction. 8 ampere going to right side path. Then what is the This is 12. 12 means 20 minus 8. That is a, I got. It's I minus I1. Dehini got? That's very important. That's why I point by point I am asking. Okay, now it is I1. It's I1. 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 It's I minus I1. I minus I1. Now again, what happened? B is another junction. Then I minus I1 and I1 again come to the same value. It is I. It is I. As example, if it is 20, I1 8, the I minus I1 it's 12. Then 8 and 12 again come to same conductor. Then it is 12 plus 8, 20. It is again I, right? It's again I. Okay, that's the circuit. I told this type circuits, we have to apply Kirchhoff law for at least 2 complete loops, at least 2 closed loops. Okay, see, I'm going to use my Kirchhoff law, A, F, E, B, A loop. A, F, E, V, A loop. I'm going to use Kirchhoff law, Kirchhoff second law. I'm going to use Kirchhoff second law into this loop, right? Now tell me, A to F, no batteries. F to E, no batteries. E to B, no batteries. B to A, yeah, there is a battery. My direction and electromotive force direction same, then it is positive E1. Positive E1 equal, positive E1 equal, again A to F, no resistance. F to E, R1, then it is I R1. E to B, E to B according to my path, E to B. This is positive because my direction and current direction same. E to B, R3 plus because my direction and current direction same. How about the IR product? It is R3 multiplied by I minus I1. Very careful these calculations. Or like this. At patterning IR magandona, we can say I minus I1 into R, both same. Okay. Came then again B to A, there is a simple R1 resistance. It's again I. It's plus my direction and current direction same. I R1. Yeah, that's all. Okay, any doubt? Any doubt? Any doubt? Amina? Sarmia? Okay. I told this type complex circuits, more than one complete loop, you have to get at least two Kirchhoff law applications. Okay. Now, therefore, now I have two options. I can use for the second loop or complete loop. I can use, but I'm going to use B C D E B loop. B C D E B loop. Okay, I can give you 2 minutes. You can try how to get Kirchhoff second law application. Okay, can you send your answers? EDCBE. EDCBE. Yes, no problem. Same loop. If not, you can get BAFDC full lecture. Both okay. Okay, I'm going to start B to C. There is a battery. It has a battery, but my direction and electromotive force direction opposite. Therefore, it's E2 minus equal, no any battery again. B to C IR 2, it is minus because my direction and current direction opposite. Okay, I'm going to use C to D, no any resistance. D to E. D to E, it has a resistance, but it is opposite with my direction, opposite with current direction. Therefore, minus I R2 capital. There is another resistance. Now it is my direction and current direction same. E to B, I'm coming E to B. E to B. Then my direction and current direction same. Then it is I minus I1 into R3. Into R3. Okay. If you have any doubt, you can ask. Tanya, okay? Okay. Fatima? Great. Okay. Now, you can use Kirchhoff law for any type of electric circuits. Okay. Now, let's move into our next paper. Get the next paper in the tube pack. Yes, this one. Okay, let's calculate first question. Okay, now very simple. Okay, you want to calculate, the question is not given, no? Okay, you have to calculate the current flowing, write down the topic, current flowing through each circuit. Okay, current summa calculate current load. You have to calculate the current flowing through each and every circuit. Okay, let's take our first circuit. Okay, this is the circuit. Okay, first I am going to label this a PQRS. First step. Second step, mark the electromotive force direction. Mark the electromotive force direction. Third step, mark the current direction. Sorry, make a value stay on 4, 3. 4 ohms, 3 ohms. 12 to 9 volt, 1 ohm. Okay, that's all. Next one, next step, current direction. Current direction. I think more than 9, 12 volt is greater, no? Then I am going to start. This is I, I, Okay. I don't know exact direction, but most possible direction I marked. I marked most possible direction. Okay. Now same method. I'm going to use Kirchhoff second law into uh, P Q R S P P Q R. I'm going to use Kirchhoff second law into P Q R S P loop, complete loop, closed loop. Okay, can you help me? Okay, P to Q. How many batteries? Only one. By my direction and electromotive force direction opposite, therefore minus 9. Minus 9. Again Q to R battery. My direction and arrow direction same. Then it is plus 12. Now no need symbols, just values. Symbols and not values done. Equal, no any battery again. I'm going to use again P. I'm going to start again P. Now my direction and current direction same. Therefore, I into 1. It is I. I into 1 mean I. 1 I. Plus my direction and current direction same. I into 3. It's 3I. 3I. My direction and current direction same. I into 2. 2I. My direction and current direction same. Plus I into 4. 4I. Now again resistance. Okay, minus 9 plus 12. What is the value? Plus 3. Plus 3 equal 1 plus 3 plus 2. 6 plus 4. It is 10I. I equal 3 over 10. It is 0.3 ampere. Very simple, right? The current flow into this circuit is 0.3 amperes. Raise hand if you understood. Not understood. Anyone? Okay. Okay, if you want, you can change the loop direction, Joel. As you asked earlier, if you want, you can take, now I got PQRSP, PQRSP. Now you, if you want, you can get PSRQP. Same answer come. Okay, let's go into second one. Okay, second one. No. Okay, that's all. Okay, I'm going to use. Okay, I want to calculate the I. Now, first of all, I'm going to mark electromotive force directions. Electromotive force directions, they are important. So identify plus minus values. Then I'm going to mark current direction. I think current is starting from this battery because it has high voltage. No? Current I only I because it's a series system. Okay, that's all. Now what's the loop? Better to use A B C D A loop. A B C D A loop. Okay, you can use any loop. Can you send me what is the value of I? I can give you 2 minutes. What's the value of I? Okay, send your current value. Final answer. Sini I got. Okay, let's see, Sarmya. Okay. Others, Tanya? Would you get? Okay, let's try. Okay, Rehna. Let's see. Okay, please, if you have any mistake, please correct. Please correct when I doing calculate. Okay, I'm going to use A point, and I'm going to find batteries first. Okay, 6-volt battery into my direction. My direction and EM force direction same. Then it is 6-volt. Second battery, my direction and direction same, 12. Third battery, my direction and EM force direction opposite. It is -3. -3 equal. I'm going to come to again A point I. My direction and current direction same, I. Again I, my direction same. 2I, my direction same. 2I plus again 2I because same direction. My direction same, again I, again I. Okay, that's all. And now 6 plus 12, 18. 18 minus 3 is 15. 15 volts equal. Or 6, 8, 10. 10I. Now I equal 15 over 10, 1.5 ampere. Sarmya, Rehlan, I think both you have. Now you're okay, Rehlan. Now correct. Sarmya, check your calculation. I think one value missed. Yeah, no plus, all are multiplication. IR product. Sarmya, check again. Fatima, correct? Samia, could you find your mistakes? Okay, please find your mistakes. Yes, not -6, no? My direction, our direction and electromotive force direction same. මේ arrow එක අපිත් එක්කම නම් තියෙන්නේ. Our direction and arrow direction same, it is positive. Our direction and arrow direction opposite only, it is coming negative. Like tree, we are come to downward direction, arrow into upward direction. That side is negative. Fatima, what is your mistake? Okay, let's move into question number 3. Okay, please start. Okay, I'll draw this on my board. Okay, that's all. You can add EM force directions first, then label A, B, C, D, or any letters. Current direction, I think this is the current direction I. Okay, I'm going to use A, B, C, D, A loop. Can you send your answers? Rehlan, I think small mistake. Please check again. Very small mistake. Okay, I'm going to start A point. No battery. There is a battery here. It is plus 12. Plus 12. No batteries. There is another battery minus 12 because opposite. Another battery plus 6. Yeah, that's all batteries. Now correct. Uh, okay, then again start a point. 3i. My direction and current direction same. I. 3i. 2i. I. Yeah, that's all. 12 to minus 12 cancel. It is 6. Equal 3 plus 1, it is 4. 4 plus 3, 7. 7 plus, oh my god, wait. What happened? It's I, no? Finally, I. It is 6 cancel. 6 equal 4, 7, 10. 10i. Then I equal 0.6 ampere. Okay, today we discussed actually very basic Kirchhoff law applications. Okay, next week, I hope to discuss Kirchhoff law advanced calculation with more than one loops. Okay, before that, you have to practice very well. You have two homework today. This is your homework. Okay, draw this question. No, this battery should be changed. Okay, you can use any direction and calculate the I. What's the value of I, the current flowing through this circuit? Okay, this is a homework number 1. This is a homework number 1. This is a homework number 1. Homework number 2. Homework number 2. Homework number 2, the paper final question. final question, question number 7. Paper, you have 3 homeworks. Second homework, paper. Question number VII 7. Okay, question number 3. You have to revise, you have to familiar next week simultaneous equation. Simultaneous equations. Okay, you can use YouTube tutorial or whatever. You have to familiar simultaneous equations for next week calculations, because this type complex calculations you have to using, you have to solve these questions, this type calculation, complex calculations you have to complete with simultaneous equation. Okay, 3 homeworks. Yeah, not only fourth one, every all questions I'm going to discuss. That's why you have to familiar simultaneous equations before that. These calculations, complex calculations, make it loops more than one loops circuits, you have to use simultaneous equations. Okay, if you have any doubt, today we discuss very advanced and very important lesson. I think if anyone absent by video, I'm not sure to cover this part by watching video. Any doubt? No. Rehlan? Understood, right? Hi. Okay, they are the homework, and let's meet next Wednesday with full calculation day, full Kirchhoff law complex question calculation day. It is very important next week class, and that means next week February, 4th of February. Yeah, February 4, the holiday, Independence Day. No? Okay, no problem. We have class. And within 2 more weeks we can complete the electricity lesson. After complete Kirchhoff law part, we have only magnetic fields, Fleming's law, Fleming's left hand rule, right hand rule, and their applications and transformers. That's all. Okay, we can quickly complete after Kirchhoff law discussion. Okay, any doubt? No, right? Okay, please go through again those questions we discussed today and practice very well for next week complex questions. Okay, goodbye. Let's make next Wednesday.